Hi guys, this is the next video, Ansible Configuration. In the last video, we looked at server provision software. In this video, we're going to take a look at steps toward a more comprehensive example in Ansible. For now, we're going to install and configure Nginx, a very popular web server, so we can showcase the main concepts of Ansible. First, we're going to create a VM in Azure with an associated static IP, so we can target it from our inventory. We're going to use Terraform in order to do it. First, let's have a look at our resources file. We use the same script as we did previously, just change the name to Nginx IP. The VM name will be Nginx. Just copy this file. Now, we run our plan so we can see what resources are going to be created. So far, everything looks right. We can apply our infrastructure. It will prompt you to enter a value. Type yes and press enter. It'll start creating the resources that we have defined. And everything works as expected. Once the machine is created, go to the VM. Click on Connect and choose the type you want to connect. I'll use SSH. Copy the command shown here. Go to the terminal and paste the command. It'll prompt you for the password that you have used to create the machine, and then you can enter the machine. If everything goes as expected, you should have a fully functional Nginx server in your VM in Azure. If we execute Ansible-I inventory all-m ping command, Ansible will ping all the hosts in our inventory specified in the parameter -i. If you change everything for the name of a group, Ansible will try to reach only the hosts in that group. Let's take a look at the output. We are experiencing problems in connecting to our remote host, and the cause is that we don't have any key that the host can validate to verify our identity. This is expected, as we did not configure it, but now we're going to solve it by creating a key pair and installing it on the remote host using the Google Cloud SDK. Open a shell in our VM in GCP. The new key generated can be found under this. Now we have a terminal connected to our VM and we can execute commands. gcloud configures a user by default. In my case, test can use sudo without password. In this case, we're going to execute the playbook as the root, so we need to be able to log in as root into the VM. Now, we will copy the file to root, and we should be able to do it. So, we have copied the public key that we generated earlier to the set of authorized keys of the root user. In order for Ansible to be able to use the key, we need to add it to the daemon on our server. This command should output the success, stating that the identity was added. Now, we will run our ping command again. The output should be very different. This means that now Ansible is able to reach our server. Therefore, it will be able to execute the playbook against it. Now, it is time to start writing our first Ansible playbook. Inside the same folder, accessible Nginx, we will create a file called tasks.yml. Then add the content to this file. This is simple to understand. Our playbook is going to affect all the hosts. The user running the playbook is going to be root. And then we're going to execute two tasks. First task is update the apt cache. And the second task is upgrade all the packages. Once we have the two files, we can run this command. We should produce output similar to this one. We're going to run a few playbooks, so I would recommend that you keep the same VM alive and run all of them against it in order to save time and resources. The trial account from Google Cloud Platform will give you enough room to run them across several days or weeks. Let's understand the output. First, it specifies against which group we're going to execute the playbook. In this case, we specified that the group is all. Then we can see three tasks being executed. As you can see, the description matches the description specified in tasks.yml. This is very helpful in order to understand the output of your playbooks, especially when they fail. And then we get a recap. 3 tasks were executed. 2 of them produced changes on the server, and 0 failed. Simple and effective is the closest to executing a script in the server that we can get. A set of instructions, a target host, and its output. In Ansible, instead of plain bash instructions, the actions are encapsulated into modules. A module is a component of the DSL, which allows you to do something special. In the playbook from earlier, apt is a model included in the core of Ansible. Documentation for it can be found at this link. Let's take another look to one of our usages of the apt module. This, as you can guess, would be equivalent to this command. So, in this case, Ansible provides us with a different module called command, which allows us to execute commands in the hosts of our inventory. Now, we take a look at this YAML. This is equivalent to the YAML from earlier, and both do the same: update apt cache. In general, if there's a module for a given task, it is recommended that you use it, as it will handle the errors and the outputs better than executing the equivalent command. Now, once our playbook has succeeded, we can expect our system to be up to date. You can check it by running the playbook again. Now you can see that there is no changes in the server. Let's see Ansible Configuration. One of the features of Ansible is the ability to override the defaults per object. In order to do that, we just need to create a file called ansible.cfg in the root of our project, and Ansible will read it and apply the configuration. There is a big number of parameters that can be configured, and all of them can be found in the official documentation at this website. As you can see, the documentation for Ansible is quite good, and the majority of the time it will provide an answer to your problems. Let's see how the configuration can help us. If you remember from the previous example, we have specified the flag -i in order to tell Ansible where our inventory file lives. Ansible has a default for this value, which is /etc/Ansible/hosts. In our little project, our inventory is in the same folder as our code. In order to specify it to Ansible, we need to create a configuration file with this content. Now, we run our playbook again with the Ansible playbook task.yaml command. We did not specify the host list, but Ansible, after reading ansible.cfg, knows that the inventory file can be located at .inventory. Ansible has a hierarchy of precedence to find the configuration. So, if we define an environment variable called Ansible config pointing to a file, the Ansible configuration will be read from that location, and the rest of the options will be ignored. This is particularly helpful in segregating environments. Our CI server can define its own configuration in the environment file, whereas developers can have the ansible.cfg file checked into the source control so that it is shared across everyone. There are a few sections that can be specified in ansible.cfg. Sections control several aspects of Ansible, such as connections. Under certain circumstances, we might need to add special parameters for SSH to work, and it's as easy as adding these lines to ansible.cfg file. In this video, we've looked at Ansible configuration. In the next video, we will see Ansible variables and templates.